Hello, friends, engineers, and developers. Welcome to another segment here of Embedded Insiders, the podcast all about embedded computing and design and all the issues in our space. I'm Ken Briota, editor-in-chief of Embedded Computing Design, and I'm so happy to be here with Felix Galindo of Digi. Felix, welcome.
Hey, thank you, Ken. Yeah, I'm
It's
Felix Galindo. Yeah, I'm a principal engineer at Digi International. I work in our OEM solutions group, which includes products from wireless modules, gateways, all the way to cloud and IoT solutions. I particularly work in the LoRaWAN space. So happy to be
That's
here.
awesome. I've been following the LoRaWAN world for a long time. It's an interesting protocol, but today we're going to be talking about the end of the world. Everything apocalyptic today, isn't that right?
Mhm.
Not really though. I think it's fair to say that in the industrial IoT in particular, there's a lot of things going on at once right now. It's we've got uh, AI sort of coming into every aspect of it. Everyone's talking about edge processing and automation and all that stuff. But um, as you pointed out, many factories and utilities and supply chain and warehouse and infrastructure operators are relying on old wireless systems, sometimes 25 or 30 years old that don't have didn't weren't built with the expectations of interoperability that we have, the data throughputs that people are expecting from all this AI at the edge, and security on its
Right.
own is a big problem. Can you give us and the listeners a sense of sort of the state of the union, where that space is now, and how to what extent this is a problem?
Yeah, I mean, I'll give a little background. So I started in IoT probably 13, 14 years ago. I think it was still called machine to machine back then. And so, yeah, I think back then, I worked on a few projects. We were still using some proprietary stacks provided by silicon vendors or even, homegrown protocols. And I'll tell you that, some of these products still exist out there, and yeah, they're having many issues trying to upgrade, right? There's some security issues, cloud integration issues, and obviously locked into specific vendors. And so, yeah, I mean, I think we're at a point, I think where things are starting to break, at least these legacy systems that were created, 15 years ago.
I mean, we're with these legacy systems. What are we talking about? Are we talking about 2G? Are we talking about a wired Ethernet? What are we talking about?
There's been everything of what I've seen from, I mean, there's been some Ethernet systems. There's been, obviously 3G, even 2G, GSM networks back in the day. I mean, some of these are already, they're starting to get replaced, but I mean, we've seen obviously issues with trying to upgrade these systems. They're costly upgrades, right?
Yeah.
Lots of development time, hardware changes, all because of you know the lack of standards back in the day.
Well, I mean, are these systems even upgradable usually, or are we talking about replacements at this point?
These are replacements because some of these radios are in these systems are, the footprint is not compatible with newer radios. The security aspect, which is a huge concern, right? The amount of flash and RAM and resources on these radios. I mean, they were a lot smaller back then, and so
Sure.
they can't support a lot of the security features needed nowadays.
Yeah, and the issue of protocols is a big one too, right? Where they're depending on sort of, often they were proprietary custom built setups
Mhm.
for all these systems back in the day, and now we've got all these standardized systems, be it Zigbee or Matter or IPv6, whatever. There's a
Mhm.
million different choices that you can have, but they're all sort of standardized. Do those protocols even know how to talk to a modern standard, or not?
These older protocols, I would say not without some hacking around, right? I think there's
So
obviously
you're saying it's fun? No.
it's yeah, it's possible that the right engineer could make it work, but obviously it's not scalable. So
Yeah. Well, I mean, you're touching on the key issue. Our listeners out there are engineers, and they are facing this problem, I'm sure,
mm,
where they're being asked to develop, many of them industrial, automation technologies, edge networking, AI enabled
mm,
computing, stuff like that, all of which is going to need connectivity, all of which is going to need often really low latency, fast connectivity. And
sure.
their clients are facility managers and systems integrators and sysadmins in these old facilities. What can these engineers do to help their compatriots, their clients in these facilities? I mean, are there ways that you can design a modern product that's going to work in a legacy system, or is there another solution? How do they start thinking about this problem?
I mean, there is retrofitting type solutions. Like I said, I don't think these are going to be scalable. You know, I hate to say it, but I think a lot of these need to kind of be ripped out, unless you can find some sort of retrofitting solution,
Yeah,
which is possible. But like I said, it's not going to be scalable. You're still going to have a weak link in the system, right? There's going to be some system in the network that has security issues, and so you know I see it difficult to really retrofit and at
yeah.
least scale. Yeah.
I mean, you've touched on this issue a couple of times, and it's a big one, the security issue. What are the security problems? I mean, are we talking just basically open networks? Are we talking about uh uh data leakage? What are the big security concerns that we're looking at?
Um, I would say, I mean, there's various, and it depends on the protocol, right? But even like uh, older Wi-Fi modules, I mean, the security has changed so much, and there's been so much improvements. Attacks on Wi-Fi networks, man in the middle, and there's been several improvements over the years, right? And so you can't just update a Wi-Fi stack on some of these 15 to 20-year-old systems because resources are constrained on these radios, and
Right.
potentially vendors are not even supporting these modules anymore, right? They have newer modules out there that they suggest to upgrade. So
Yeah. And not to mention the fact that a lot of these old systems don't support, over the air updates and things like that. You just can't push enough data through, even if you wanted to just handle it from a software point of view. Is that right?
that's right. I agree with that.
Yeah. So, to look at it from the other side, because we've certainly got listeners out there who are these facility sysadmins, and they're looking at their OT infrastructure or whatever, and
Hmm.
seeing the edge of the cliff come a lot closer lately. What can they start doing to get ready for this probably inevitable upgrade where they're just going to have to, as you say, rip it out and put in a new system? Are there steps that they should be taking now to upgrade their connectivity to move through, or should they just be looking at, I need to start figuring out how to put budget toward this?
Um, yeah, I mean that's a good question. I mean, I definitely think there needs to be some budgeting and planning towards the future. You know, proper designs of systems that include protocols or modules that have, they're going to have long-term support. I think we're touching on standard-based wireless systems, right? And so ideally going towards something more standards-based, right? That's going to have a community behind it. That's going to support and grow. I think it's important to start planning. It's just going to be needed.
Yeah.
You can retrofit, but I think long term it's going to be required.
I know Digi's always been pretty platform neutral. You guys will
Mm,
service and work with pretty much whatever protocol is out there, as long as it's secure and doing the job properly and
right.
everything else. But as these industrial operators are looking to shift toward more open, more standards-based architectures, I mean, I assume that you generally would recommend open architectures rather than sort of closed proprietary situations, right?
I would say so, at least from the protocol perspective. Yeah, I think some open standards is what I would suggest. I think trying to develop your own protocol, um, it's a huge task, and I think as there's newer and greater applications out there that we're trying to solve. Right, there's Edge AI, Tiny ML, right? And you want to spend more of your time in that and not really spend time on developing, your own protocol.
Yeah,
And so I think going with the standards base, I mean, you're leveraging resources, engineers who are working on these standards and dedicating a lot of time. Whereas if you develop your own protocol, you're dedicating a lot of engineer resources to build your own protocol, right? And so rather than that, it's better to spend more time on your solution, right? On your what
right.
you're the value you're trying to provide. So
Yeah. That makes sense to me. I'm so glad to hear you mention Tiny ML. I feel like I haven't heard a lot about that in the last, 6 or 8 months, and I always liked that protocol. I always thought it was a good one, and it's glad to hear people are still talking about it.
yep.
Um, and great branding, honestly. It just sounds adorable. Everyone should be using it. Um, so let's talk a little bit about, as I said, Digi's pretty agnostic to protocol, but do you have any favorites for certain use cases? Do you recommend, like, hey, you're in a factory manufacturing environment, you should probably be looking at these architectures. You're in a warehouse or transportation environment, you should be looking at these. I mean, do you have any sort of favorites by those silos that you recommend?
Yeah, I mean, probably a little biased towards LoRaWAN, but I think LoRaWAN, it's a narrow bandwidth protocol, but there is a lot of use for it. We have a particular agriculture application that we're working with a customer, and it's the low power piece of it has been vital to building this solution, which needs to operate off a small battery for many years. And so, LoRaWAN, I think agriculture, I mean, there's smart city, you're targeting rural type applications where you need that long range, and there's also some satellite work that's being done in the LoRa space. Um, but LoRaWAN, I don't think it solves everything. And as you mentioned, Digi's quite protocol agnostic, so we do have modules that share same footprint but have different protocol support. And one of our newer ones is YSUN, which there's another team involved in that. But YSUN, there's a lot of use cases in smart city metering type applications. So. And you have some of your classic. You have cellular based. You have Bluetooth, Wi-Fi. But in terms of industrial IoT, I mean, LoRaWAN, YSUN, those are still kind of our top at
Yeah.
Digi, and we do have also Digi Mesh.
I wanted to ask about that, the IPv6 mesh, because I think it's interesting, but I haven't seen a lot of, like, field cases yet, or anything like that. And I'm sure you're closer to it. You might have seen some. What are your feelings? What kind of clients are using the mesh?
Um, so in terms of IPv6 mesh, I think I'm not too particularly involved in that area, but I do see, for example, smart home applications, where you have a mix.
Okay.
You have IPv6 based systems that need to you know integrate with other types of
Yeah.
networks, Zigbee or whatever it may be.
Matter or
But
whatever. Yeah.
exactly, there's Matter out there. So there's quite a bit of work being done there with collaborating between protocols like LoRaWAN with
Right.
say other protocols like Wi-Fi.
Um, are there advantages to multi-protocol chips and things, or is it better to just sort of pick the one that you think is right for you and sort of lean into that?
There's definitely a good use for it. I mean, if you're referring to things like roaming, for example, you might say, for example, there's Amazon Sidewalk out there, right? You
Sure.
might be in a home environment, and then the device might travel out to somewhere else, right? And you want to be able to switch over to a different protocol, right? And so I think there's definitely a use case for that. I know Amazon Sidewalk, for example, they do provisioning over Bluetooth, and
Yep.
so and you might want to do things like firmware updates over Bluetooth versus do it over LoRa because of the bandwidth constraints. So I think it's definitely very useful, and I do see that growing in the next few years.
Awesome. Um, Now let's talk about a little bit about sustainability and length of life and that kind of thing as we get near the
Hmm.
end of our time, because we're talking about legacy systems that are sometimes, yeah, as I said, 30 years old,
Sure.
and using, if they're connected at all, and of course a lot of these older facilities just aren't using connected infrastructure at all and are looking to. Um, so whether or not they're replacing or they're adding in, they're going to want to know about life cycle. They're going to want to future proof their design as much as they can. What are some recommendations that you would make for engineers looking to be thinking about that kind of aspect, that future proofing, that making sure they're choosing a standard that's going to be around for a while, stuff like that?
Yeah, I think you're going to need, what I would suggest is a right, module partner, or wireless solutions partner. I'm going to be biased and suggest Digi, right? But making sure you're selecting, a module partner that's going to help you maintain over those years, right? I think Digi's been great at that. We have similar or shared footprint across modules, and as far as I know, we're going to maintain that. And so if one day you're doing LoRaWAN, and then 20 years there's a new protocol, and we're still using the same footprint, then you can easily swap that
Swap it.
out without much yeah, board spin, basically. And then obviously these, the modules we're working on, they share a same set of AT commands and API frames, which makes software development, easier, right? If you're going to switch to a different protocol, there's a reduction in how much work is needed to you know upgrade your software, essentially. And so I think choosing the right partner that is has that in mind, right? That you're trying to maintain over the years, and it's important. I think partner, basically.
You know, this I like to, when I get the opportunity, ask a question that I also get to put the disclaimer on. You don't have to answer this if you don't want to, but it's
Mm,
something that I'm interested in, and I think the listeners might get a kick out of hearing us talk about for just a second. Um, when it comes to Edge AI and all of the data throughput that's needed there and everything,
mm,
it seems like right now mostly all of the discussion is around cellular or satellite supported cellular, but it's all, 5G because they're trying to put so much data through.
sure.
Um, but that's an energy problem. They all want to be low power, low energy, and I know cellular's gotten better about that over the years, but it's still one of the bigger drains.
Mm.
Do you expect cellular to stay the sort of king of the AI transmission protocol, or is there another player in that space that you would expect to sort of take the lead because of power efficiency or anything else while still be able to handle the data throughput?
Yeah, I don't think there's going to be one single protocol that wins. I think there's going to be multiple. And in terms of edge AI, it's going to depend on the application because you're talking a wide range of applications. There's computer vision applications, and there's simple anomaly detection,
Sure.
edge AI applications where the bandwidth requirements aren't as high, and so things like LoRaWAN can support edge AI applications in those scenarios. But yeah, for some of these higher type applications, higher bandwidth applications. I mean, cellular is going to still be big. Wi-Fi is going to be big,
Yeah.
and so, but I don't think one protocol is going to it's going to be the king of all of them in terms of edge AI. I think it really depends on the application.
As always, I have to condemn you and say, how dare you be reasonable and give a measured and nuanced response to my clear attempt to get you to say something spicy. Uh, Um, the question I always like to ask at the end, Felix, is what didn't I know enough or think to ask you about that the engineers listening really should know in this world of legacy industrial IoT connectivity? What should they be thinking about where in this arena?
Well, I think edge AI is still a very hot topic, and it's something near and dear to me. I spend a lot of time in the edge AI space. In terms of edge AI, there's still a lack of infrastructure, and wireless networks play a vital role in edge AI. And so, keeping in mind that you might want to do things like upgrade models in the field, that sort of stuff. So, you need to choose appropriate protocols or design your payloads in a way that best leverage your protocol to do what you're trying to do in edge AI. So um, a lot of interesting things happening in edge AI and in IoT and how they work together.
Awesome. Well, thank you so much, Felix. Really appreciate you taking the time to chat with me today and giving us sort of your perspective on, I think, a looming and big issue that a lot of folks out there listening are going to have to face.
Yeah, thank you, Ken. Thanks for having me.
Thanks, everybody. Hang around for the next segment of Embedded Insiders and make sure that you subscribe to our podcast, subscribe to us on YouTube, depending on where you're watching or listening to this, and make sure that you hit the notifications on that no matter where you listen or watch. You don't want to miss any of our episodes of any of our programs. I've been Ken Briota, Editor-in-Chief of Embedded Computing Design, and your host, and we'll catch you next time. Thanks again, Felix.